Hello, my name is Rob Reynolds. Today we're going to do Chapter 7 in Mat-073, specifically looking at Section 7.6, and we're graphing quadratic functions. And if you haven't watched a previous video about how to convert a quadratic from standard form ax squared plus bx plus c into vertex form, then I would suggest that you watch that video first, because that's the first thing we're going to do in this video, is to translate or transform from version A to version B. This way it'll be a little bit easier to find the vertex, which is h and k. If you're in this form, the standard form, then the vertex can still be found, but we would have to do a formula. Vertex is negative b over 2a for the x coordinate. And we're also going to talk about how to find x-intercepts and y-intercepts, and again look at some symmetry. So completing the square, again, is the process of moving it from standard form to standard graphing form. And again, this allows us to find the vertex a little bit more easily. So here we go. The vertex is not given here, so I will try to complete the square. So y plus 1 is equal to x squared minus 2x plus some number. And so to complete the square, I'm going to throw this over on this side. You don't have to do that. The book doesn't do that, so the book teaches this just a little bit differently, but I think it's easier for students to see. Let's just get rid of that 1 altogether, unless that is, 1 is a perfect square, but I don't think it's the perfect square that I need. If it would have said x squared minus 2x plus 1, then I think I wouldn't get rid of it, because this is already x minus 1 quantity squared. I think I could, it's already a perfect square. But this negative 1 is not the perfect square that I need, so to find the number that I need to add to this side in order to complete the square, I'm going to do the star step, taking half the middle term and squaring it, and like I mentioned earlier, that number is going to be a 1 that I'm going to add to this side. 2 divided by 2 is 1, 1 squared is 1. So if I add 1 to this side, I better add 1 to this side. So the total over here is y plus 2 is equal to, and then all of this factors to x minus 1 quantity squared. The last thing I would do is just subtract 2 from both sides. Again, the goal is to get it into this form, y is equal to a, x minus h quantity squared plus k. So now I can see that the vertex is the opposite of this divided by the negative 2. So remember, whenever you see parentheses, go the opposite direction. So the vertex in this case is 1, negative 2. And the value of a is very important, because we always go over 1, up a, or down a. But since a is positive, I'll go up a. So I'll find some other points on the parabola. So over 1, down 2 is the vertex. Over 1, up 1, over 1, up 1. And that's a pretty good graph right there. If you want to find additional points, you could go, again, over 2, up 1, 2, 3, 4 to find another point. And I could continue this process over 3, up 9. So find the vertex. The line of symmetry is right here. It always goes through x equals the x value of the vertex, in this case 1. And then the minimum value would just be the vertex. This is the minimum, the lowest point. 1, negative 2. So the vertex and the minimum are the same. The graph opens up. Negative 2 is the minimum, the y-coordinate. Alright, so for this one, to complete the square, it's a little bit more difficult because we have a leading coefficient, so I can't complete the square with a leading coefficient. I'm going to add 3 to both sides and factor out a 2, because the star step, half the middle term squared, can't be completed until I have a leading coefficient of a 1. So if I factor out a negative 2, this literally divides each of these terms by negative 2, giving me a negative 3x, and that means I'm going to have some fractions here. So if I take half of 3 and square it, I get 9/4. And 9/4 is the number that I'm going to add to this side. However, I didn't add just a total weight of 9/4 on this. I actually added -2 times 9/4, which is -18/4 to both sides. So this 3 is really 12/4, and 12/4 take away 18/4 is -6/4. -6/4 minus, or y minus 6/4 is equal to -2. I'll complete the square over here. X minus 3/2, and I know that it's a 3/2 because whatever this value is here, that just comes down here. Whatever this sign is here, that comes down here. And then my final step would be to reduce the 6/4 and add it back to the other side. So x minus 3/2, I'm going to add 6/4 reduces to a 3/2. So the vertex, not nice. 3/2, 3/2, which is around 1.5, 1.5. And then the value of a is -2. So instead of going over 1 up 1, over 2 up 4, I multiply this value of a by the y value. So I'm going to go over 1 down 2, and then over 2 down 8 on both sides. So from here, I'm going to go over 1 full unit and then down 2. I'll do symmetry. And if I wanted to find additional points, I could go over 2, down 1, 2, 3, 4, 5, 6, 7, 8 off the graph. Something like that. The axis of symmetry is right here at x equals 3/2. The vertex we got right. Every time the graph crosses the axes, it's called an intercept. So we have y-intercepts and we have x-intercepts. To find a y-intercept, you let x be 0. To find an x-intercept, you let y equal 0. So this would be an ordered pair, something, comma, 0. This would be an ordered pair, 0, comma, something, but that something is always c in this form, where c is always the last number, as long as it's in that form. So the y-intercept here is 0c. And to find the x-intercepts, we would have to factor instead of equal to 0. Let me show you what I mean. Trying to find x-intercepts, we can't find, there's no this doesn't factor. So if it doesn't, and then I wish I could have shown you an example where it did factor. We would just factor and set it equal to 0. But for this example, we'd have to use the quadratic formula where the value of a is 1, b is 3, and c is -1. Reviewing a lot in this video. -3 plus or minus the square root of. I taught the quadratic formula in a previous video as well, so you may want to review that all over 2 times 1. So -3 plus or minus the square root of 9 plus 4, which is 13 each. That does not reduce, so I'd probably just go to my calculator and figure out what -3 plus the square root of 13. I should probably put that in parentheses. And divide that by 2. So there's one x-intercept. The other x-intercept, if I just hit second enter, it's a recall key, and I can just, and that's why I didn't want to press enter more than once. All I have to do is change that to a minus now. So I think those are my 2 x-intercepts. The y-intercept is easy. The y-intercept is right here at -1, so I found that point. Plotting the other 2 points it's kind of difficult. It's going to be a little bit of a guessing game. But again, -3.3 is about here, and 0.3 is about here, and of course we found the y-intercept at -1. They didn't even ask me to find the vertex here, but I certainly would have by doing the -b/2a process. Remember that you could always find the vertex on your graphing calculator as well, and if you don't know how, I'll refresh your memory here. X squared plus 3x, typing this in, minus 1. I'm going to zoom 6 because sometimes I mess around with my window, and zoom 6 will set it back to a standard 10 by 10 by 10 screen. If I hit second, calculate, I'm going to ask for the minimum because that's going to be the vertex, so I'm going to hit the white key 3. I'm going to guess to the left by typing in like, oh, maybe a -8. Press enter, and I can see that's a left bound. I'll type in a 1. So then it says guess what's between my two -8s and 1s. I think the vertex is around -2. I'll press enter, and there's the actual vertex at -1.5, -3.25. So I think that's helpful information. -1.5, -3.25, and because that locates this point right here. The book will also be asking you to find the vertex, the line of symmetry, the max and the min. And sometimes they say, well, just here's a t-chart and plug that in, but I wouldn't do that. The purpose of this chapter is not just to plug in a 1 and plug and chug and find a y value. If you find yourself doing that, I would stop, because your calculator will do that easily enough for you. You can get an instant t-chart by hitting second graph, and there's a bunch of values for x and you solve for y, so there's no reason to plug in for x and solve for y. What I'm trying to teach you is that the vertex is always defined as -b/2a, completing the square. The line of symmetry is always the -b/2a, the x coordinate of the vertex. And then we either have a max, let's see, if it's positive, if a is positive, we're going to have a minimum, and if a is negative, if it's y is equal to -x squared, then we would have a maximum. So I'm just trying to show you some different things of the graph. So for example, I would be interested in you knowing that the vertex, in this case, you could complete the square, but we could do -b, which is 7 over 2 times -4, is -7/8. But then I would probably just go to the calculator and evaluate the function at -7/8, because I just don't see the value of plugging and chugging when we have great technology here. Minus 7x plus 2. Of course, the calculator would have found the -b/2a as well, but so I would just hit the trace -7 divide by 8 to find the vertex of 5.0. If you want to convert that 5.0625, just hit second quit and type in 5.0625 and hit math, enter, enter, and that'll convert it 81/16. Then no one will ever know that you used a calculator. They'll think that you number crunched it and you reduced your fractions. That's great. The line of symmetry would be the x coordinate as well. So if the vertex is -7/8 and then 5.0625, then the axis symmetry is this x equals -7/8. Since this is going down, we're going to have a maximum. So I would put maximum value here, and the maximum value is this 5.06, which we just learned is 81/16. With that information, you should be able to graph this function. Remember, after you find the vertex, you're going to go over 1, down 4 on both sides, because you've got nice symmetry about this x equals -7/8. I hope you found this video helpful. Email me with any questions. Thanks.